Hey y'all, Data Guy here, and today I have a video for you on a really cool new tool, open source library that one of my followers put me onto. So just showing you, hey, if you have a viewer request, let me know and I'll make a video on it. But in this case, what we're going to be talking about is polars. Now, polars is essentially a replacement for the pandas that we all know and sometimes love. I love it, but apparently a lot of people don't out there. And what polars aims to be is basically a better, more efficient way to do a lot of the same operations that you would do within pandas, and really just kind of upgrading some of the functionality of pandas into a more multi-threaded, kind of modern cloud-based approach. So what I'm going to go through in this video is first just give you a quick primer on kind of how polars works, how it differs from pandas under the scene, and why people want to use it. And then I'll go into breaking down a script and showing you how you can write equivalent commands in polars versus pandas, so you have an idea of how you can actually get started using polars in your own scripts and use cases. So without further ado, let's get into it. So polars has a few different compelling advantages over traditional data manipulation libraries like NumPy and Pandas, mainly due to better performance efficiency and scalability. So it's really built from the ground up with a focus on speed and memory optimization and handling larger data sets that could overwhelm libraries like Pandas, which isn't really meant for super large data sets since it operates with a single threaded approach. Polars, on the other hand, actually leverages Rust under the hood to do much more efficient memory management and multi-threaded execution, which allows it to process data much faster. And you can see some of these benchmarks here of exactly how much faster it performs versus tools like Pandas or even PySpark. And so this has really made polars very popular for big data applications where filtering, aggregating, joining large data sets can be handled without really a ton of memory overhead like Pandas might require. And one of the standout features that enables this decrease in overhead is its support for lazy evaluation. So Pandas, which immediately executes each operation, which makes it much more kind of computationally overhead, polars will only compute results that are explicitly requested. So if you don't explicitly ask for that computation, polars won't make that execution. And so what that means is polars can actually then optimize the entire sequence of transformations, and that can result in significant performance gains by not transforming data that doesn't need to be transformed. And this also enables polars to apply operations like filtering and joining more efficiently and reducing the time and resources needed to perform multi-step complex data manipulations. Additionally, lazy evaluation is super beneficial for workloads where transformations are applied in a series of dependent steps, because polars actually has logic in it to reorder those operations under the hood to minimize redundant computations if it detects there might be some. And then finally, polars provides a really versatile and functional syntax that we'll get into in a second that's well suited for data manipulation tasks, advanced operations like window functions, rolling computations, and its native support for those more complex functions makes polars a really good choice for real-time analysis, time series analysis operations where you're going to need to do a ton of operations on a really frequent basis. And also, because polars is designed around minimizing memory usage, lets you work with much larger data sets than you might be able to handle in Pandas. So it's a great tool for memory constrained environments or just like large scale data engineering workflows. But in summary, polars is a really powerful alternative for anyone needing higher performance, scalability, and memory efficiency. And with its multi-threaded execution, lazy evaluation, and functional approach to data transformation, polars lets you do more complex data tasks faster, more efficiently, and more reliably. So now that you've kind of heard the spiel on why polars is so great, let's kick it over into VS Code, and I'll actually show you how we can get started. So here we are in a local development environment, just in VS Code. Obviously, run wherever you want to run Pandas. And to all we're going to do to actually install polars is going to be pip install polars. And then this should install into my local Python environment. And then once I'm done, so I'm going to load in Pandas and Polar to show you how you can read in files. So first thing here, for just reading data from a CSV, pretty similar syntax. So Pandas is imported as PD. Polars is imported as PL, not really that complex. And then here you have read CSV, data.csv, or data.csv. It's the exact same syntax. However, under the hood, Polars is going to be using multi-threaded I/O by default, which is going to load data significantly faster than Pandas. So even though it's pretty much the exact same syntax, it's not really more complex to use, your actual data loads will be much more efficient if you're using Polars instead of Pandas here. Now, just so we have some dummy data to play with, I'm also going to show you just how you can create some simple dummy data in both. So just going to create the same sample data here, and then just run the cell, just switching over to using Jupyter, so just easier for me to just show off what I'm building here. So number one, just cleaner in the UI, kind of more table experience than Pandas for Polars, which I personally love. Some people that I care about, but I think is nice. But just showing you the data that we are actually working with. So next, to go into kind of some other ways that how Pandas and Polars work or differ. Next step is just basic data exploration. So here, I'm actually undo because I don't want to do all of that. I just want to add it here. So I'm going to have the data. So here, showing you how you can print different data types and summary statistics. So here at the top, you have the Pandas option where you kind of see different data types, summary statistics of it. Here, however, you see a bit more granular on the actual column level. And also, Polars operations are generally faster here, again, because it's using lazy evaluation and only computing those values when needed. But something like Pandas is going to be really comprehensive for small or medium-sized data, but really slow if you start to do in-depth summaries of much larger data sets. Now, next operation I want to show you how to do is data selection and filtering. So let's say we just want to select a single column and then filter it for a given set of data. So here, what we do is just have column Pandas, column name for each of these, and then let's put in category. And just copy and paste that through all of these. Column name. And, oh wait, that's not even going to make sense. Sorry, let's put value actually. So value. And none of these are going to fit, so that's going to be cool, but at least we'll show you kind of how this works. So value, calculate it, and yeah, nothing's going to show up because nothing's over 50, so let's put this 10. Put this at 10, and then run it again. Oh, and then print. What am I doing? Print. And print. Awesome. Let's save this. I don't need to save it. And here you can just see quick filtering. And again, this is on a smaller scale, but this, Polars uses a vectorized query engine, so each piece of data is broken down into the underlying chunks, and then that means it can filter with much higher speed because it only needs to filter over the numerical values, not the more qualitative values. So it works really well even at scale of large data. And then Pandas has an intuitive syntax, just kind of as Polars does, in my opinion. You're just adding this dot filter instead of just kind of adding it in here without a strict definition. So maybe you like that better, maybe you don't. But I personally like the more declarative definition of Polars. And another issue here is Pandas is going to be much slower for larger operations versus Polars is going to have the effect of that vectorized query engine really take place once you have really large sets of data. Now next, so both tools support adding new columns, renaming, deleting columns. But Polars uses method chaining and lazy evaluation for optimization there. And so method chaining allows for more concise, readable, and performant workflows versus Pandas. You need to be a little bit more verbose, especially when you're chaining multiple operations. So here you can see kind of some example operations here. So Pandas, to rename a new column, you set new column equal to column name times a value. So this is just bringing in one of those columns and setting it as a column name, or setting it as a new column. So this is just going to be, let's say, value times 2. And then here you have similar definition, but just more I'd say like methods. So instead of Pandas kind of hidden definition where it's say, hey, this is going to be equal to column, you're going to declare with a new column, add it from this alias. I don't much care for this alias piece. This is kind of confusing. But again, this kind of method chaining does allow for more performant workflows when you're adding more additional methods. And you can see similarly for renaming columns how that works. But here, let's go down and print df pandas and df polars just to see the output. And again, see some of the changes here. So with column, so let's see what's happened there. So it looks like this one doesn't have a column enabled, but this is how you would be doing it. Let me see if there's been an update to polars that I'm not aware of. Check this out. Needed an S. So we just need the with columns, and then let's run this again. And awesome. So I figured that out, but effectively what you'd have here is you have just a sequence of different methods rather than this kind of, hey, set one value over another style that Pandas has. So with Pandas, you can't really chain multiple operations, versus with Polar, you can actually chain those multiple operations. Next, we have aggregation and grouping. So grouping and aggregation in Polars can be significantly faster because it has an optimized backend for group by transactions. However, and you can also see this kind of more chain methodology here rather than just having one method or kind of the dot sum. So here you have different chains of methods as you're grouping and then aggregating by sum. And the multi-threaded execution of polars makes this aggregation much faster, especially with larger data sets. Versus Pandas is only ever going to be single-threaded, so it's going to slow down as you have larger data sets or more complex aggregations there. Another operation that's efficient with polars versus Pandas is merge operations. So polars can perform joins much faster than Pandas, especially with larger data sets. Again, because of that multi-threaded processing and lazy evaluation. Pandas is versatile in multiple join options, but limited in performance with those larger data sets, versus you have all those same kind of join options and you have it done much more efficiently with polars. So just much better way for joining really large data sets just because of that multi-threaded nature that polars provides. Now next, and this is a really unique feature of polars, so I can't even really show this for Pandas, and that is rolling average and window functions. So these are functions that allow you to calculate a transformation with time series analysis over a period of data. So here you can see I'm trying to calculate the rolling mean on the value method of this data. So let's run this. And awesome. So we're getting screwed by this with column again. And let me open it up real quick. So cool here. And with columns. And then play again. And awesome. So here we have the rolling average. And so you can see much easier way to calculate and implement these functions over large periods of time and reduce the need to run it many times over different time periods. Versus Pandas, you would need to do much more manual effort and then also going to be much slower with those transformations. So really cool, really easy to use feature that it just gives you immediate, kind of unique value add over Pandas. Now, finally, we have actually applying lazy mode calculations. So this isn't really going to seem like much, but when you're dealing with really large scale calculations, what you can do is create a lazy data frame and then apply transformations in lazy mode. So here, let me actually put value, put this over 10, put value here, and then run this. And what this will do is just run those calculations in that lazy mode I described earlier, where it's going to optimize the entire chain of transformations, executing once only all the operations are defined. So it knows, hey, if it knows later down on the train, you're actually not going to need this data, it's not going to calculate that transformation on it. So it's not going to, let's say, average data that isn't actually going to be used later down in the chain. Versus Pandas uses the eager execution, so each operation is going to be calculated immediately, which can lead to much slower execution times with longer transformation chains. So in summary, performance, polars outperforms Pandas in speed, memory usage, especially for larger data sets or complex operations. It's also much more memory efficient due to its design, so much more beneficial when working with large scale data. And then the only thing where Pandas might win, and that's just really because of familiarity, is there's a slight learning curve with polar syntax. As you can see, a lot of it's mainly the same, but it's just changing out slightly where different things are, what different things are called. And its functional style and support for lazy evaluation can lead to much more efficient code, especially as you're growing in complexity, and so are all of your queries and transformations. But that is all I have for you today. I hope you've enjoyed this video. I hope you have a great rest of your day. Data Guy out.